Hi guys, welcome to lesson 10.6, picking up on page 187 in your book. We've got two objectives here. We want to be able to solve systems of three linear equations in three variables using substitution or and Gaussian elimination. And we want to be able to formulate, in other words, come up with by ourselves, systems of three linear equations in three variables to model a situation. And then obviously we'll use those first skills, substitution or Gaussian elimination, to solve it. So this is a great lesson. It is not for math sissies, that's for sure, but you guys are ready. Remember everything you've learned about substitution and elimination, and if those aren't strong, don't try this. It'll just blow your head off. All right, here we go. Sometimes a situation has more than two pieces of information. For these more complex problems, you may need to solve equations that contain three variables. Read and discuss the material on this page with your group. That's me. I'm your group. Before you move on to example A on the next page. So we're going to clarify the meaning of some mathematical concepts and other language used to describe the information. We want to just make sure we're coming at this with enough background, okay? Travis and Roy's charges for trucking produce are based on crate size. In one trip from Pecos to Dallas, they hauled 22 small, 8 medium, and 35 large crates for $876. On another trip, they hauled 60 small, 5 medium, and 7 large crates for $772. And on a third trip, they hauled 19 small, 23 medium, and 21 large for $802. How much do they charge for each size of crate? So the problem above represents a system of linear equations in three variables. So we've got small, medium, and large crates. And we can represent them with these equations. This part probably won't be too hard for you to understand. So the red one had 22 smalls, 8 mediums, and 35 large, and it cost $876. And then the middle one had 60 small, 5 medium, and 7 large for $772. And then the other one, the third one, had 19 small, 23 medium, and 21 large for $802. So we've got this system. We've got three variables, three equations, and we're going to learn how to solve that now. Although it's possible to solve systems of equations in three variables by graphing, it can be difficult, especially for those of us who don't see in three-dimensional drawings very well. So just as the ordered pair xy is a solution of a system in two variables, the ordered triple xyz is a solution of a system in three variables. So ordered triples are graphed in three-dimensional space. So the point 3, -2, and 4 is graphed below. So you'll see your x axis is this one, okay? Your y-axis is this one, because that's the way they have it labeled. And your z-axis is this one. And that's just the way they've told you the coordinates are for this one. This plane could rotate and turn any direction. So x, y, and z could be in different positions at different times. So you just have to say, here's how it's oriented. And so on the x-axis, you would go to 3. So here's 0. 3 forward as opposed to 3 backward would be right here. And then on the y-axis, you're going to go -2. So that's 2 units left on the y-axis. So from 0, that'll be 2 units to the left. And then 4 units up will be right here. So you go 2 units to the left from your x-coordinate, 4 units up. So we're not going to spend too much time belaboring that because, as they said, that can be difficult. We'll let you get to that in a little bit higher level math. So we're going to learn to solve these algebraically so that we don't have to do this kind of sketching. All right, so let me yell at the dog just a minute, please. All right, Kevin was appropriately ashamed of his ridiculous canine outburst, and he apologizes. Okay, so the thing is, stay relaxed here, all right? And they explain every step to you here. It just might take more than one pass over this for you to get it. So you might have to read, watch, read, try until you really soak it in, and then you'll see, oh, that's a pretty simple process. There's just, it looks complex, okay? So we can use the substitution method to solve these systems, and this example walks us through it. Here's a system of 3 equations right here, okay? Not the ones from Roy and Travis, but a new batch. So what we do is we solve the first equation for z. So we would minus 2x from both sides, minus 7y from both sides, and then we'd have z equals this. Okay, so that's step 1. Solve the first equation for z. Step 2. Substitute the expression for z into the second equation. So right there on the second equation, I'm going to put this stuff that equals z in there. So instead of z, I'm putting in what equals z, which is the negative 2x minus 7y minus 53. All this stuff right here equals z. So I'm replacing z with that. And then we clean that up and combine like terms and solve it for y. Okay, so you probably want to try that on paper and make sure you follow all that, but you would end up with, you combine like terms and you'd have to add 4x and 53 to both sides, and you'd end up with, and then divide by negative 4 to everything. Then you end up with y equals negative x minus 10. Now, do not just take my word for it. Do that on a piece of paper, because if you make sign errors getting y by itself or z by itself, this is never going to work. There's so many little steps to it, okay? So just take the time to make sure you can solve for those variables. Then it won't be a big deal. All right, so the next step is use substitution to solve the third equation for x. So we're going to take this, okay, y equals this stuff, and we're going to substitute this stuff for y in the third equation. So it's going to go in right there. See, if I'm back on this original system, it's going to go in this third equation for y right there where I just drew that little arrow. So 6x plus 3y plus z equals negative 45. So now we're going to plug in what equals y and what equals z, okay? So these things we found here, this equals z, this equals y, and we're going to make those substitutions. So first they plugged in z here and they cleaned it up a little bit. Then they plugged in a y here, cleaned it up some more, and they solved it. Because then there was only one variable left. If you replace with substitution, you replace the variables, then you're going to end up with one variable. So step 4 is solve the last equation from step 2 for y. So here's where we solve for y. And now we know x is negative 4. So y equals negative x. So that's negative negative 4, which is 4, minus 10. So y equals negative 6. And now we're almost there. We'll go to the last equation from step 1 when we got z by itself. So right there. And we're going to plug in x and y. So we know that x was negative 4 and y was negative 6. So we clean that up and we get z equals negative 3. So here is the ordered triple, which is the solution. Negative 4 for x, negative 6 for y, and negative 3 for z. So it's really just a matter of repeating step after step after step and not making sign errors, and it won't be too hard for you. As a final step, check your ordered triple to make sure that your solution is correct. This x, this y, and this z should make all 3 of these equations true. Don't cheat yourself. Check it and say you're right. All right, this is your chance to try now. I would definitely you use a separate piece of paper. You don't have enough room to do these in here. I'm going to just do one on this page. So definitely try it by yourself, mess it all up, and then play this. But see how far you can get by yourself following those steps. You're going to have to use everything you know about clearing fractions and solving equations, being careful with signs, okay? So we're going to solve this first one for z, and that would give us z equals negative x minus 4y plus 3. So that's what z equals. Then we're going to substitute that in the second equation to figure out what y is. So 2x plus y plus negative x minus 4y plus 3 equals 11. So 2x plus y minus x minus 4y plus 3 equals 11. So that would give us x minus 3y equals 8 when I clean up those sides. And then I would subtract x, so I would get negative 3y equals negative x plus 8. And then I would divide everything by negative 3. So I would end up with y equals 1/3 x minus 8/3. So that's what y equals. Now, we're going to use the third equation, right? And we're going to substitute in z and y. But we'll do it one at a time so we don't get overwhelmed. And we're going to figure out what x is. So first, 4x plus y plus 2, and we'll substitute z in first. So negative x, oops, sign error almost, minus 4y plus 3 equals 23. So I'm using this last equation, and so far I just substituted z in there. So that would give me 4x plus y minus 2x minus 8y plus 6 equals 23. Being careful with signs. So when I combine like terms, I would get 2x minus 7y, and then I'll minus 6 from both sides. So I'll get equals 17. Okay. Now I'm going to go ahead and put my y in, okay? So here's what my y equals, this blue stuff right here. And I'm going to put it in right there for y. So I'm going to bring all this over here and keep going. So I would have, let's see, I'll change the color here. So I'll have 2x minus 7 times, and for y, I put in 1/3 x minus 8/3. Equals 17. Okay, so that would give us 2x minus 7/3 x plus 56/3 equals 17. Now I'm going to multiply everything by 3 to get rid of those fractions. So that would give me 6x, this one cancels out, minus 7x plus 56 equals 51. So negative x equals minus 56 on both sides, negative 5. So x equals 5. All right, so I have one part of my answer already. X is 5. Now it gets easier because now we go back to each of these boxes here. Now we're going to solve y, and then we're going to solve z. So when I come back to this one for y equals 1/3 times 5, that's what x is, minus 8/3. So that means y equals 5/3 minus 8/3. So y equals negative 3/3, which equals negative 1. So now we know what y is. And now we can do the last step, which is z, okay? So z, coming back to this box up here, okay? Z equals negative x, which is 5, minus 4 times y, which is negative 1, plus 3. So that means z equals negative 5 plus 4, because negative 4 times negative 1, plus 3. So z equals negative 5 plus 4 is negative 1, plus 3 is 2. So I got my ordered triple solution is 5, negative 1, 2. And if I plug that in for x, y, and z into all three of these equations, it will make them all true to prove my solution. All right, so let's try this other one now. So first we're going to solve this one for z. So z is going to equal negative 3x minus y plus 5. So that's what z is. All right, so then in the second equation, I'm going to plug that in for z. So that would look like x plus 2y minus 3 times negative 3x minus y plus 5. And that needs to equal 15 because I'm using the second equation. All right, so when I clean that up, I'm going to get x plus 2y plus 9x plus 3y, careful with your signs, minus 15 equals 15. So then I'll combine like terms, so 10x plus 5y minus 15 equals 15. So then when I get y by itself, I would get 5y equals negative 10x, and then I'm going to add 15 to both sides. So I'm going to get plus 30. So when I divide everything by 5, y is going to equal negative 2x plus 6. This one's a lot nicer, isn't it? Negative 2x plus 6. All right, so then I go to the third equation, and I substitute z in and y in. So we'll do one part at a time. So let's see, why don't I see if I can bring it up over here and make it fit. So let's see. 2x minus y plus z, which is negative 3x minus y plus 5, needs to equal 2. All right, so cleaning up a little bit, I would get 2x minus y minus 3x minus y plus 5 equals 2. So negative x minus 2y equals, and I'm going to minus 5 from both sides, so negative 3. Now I can plug y in, so negative x minus 2 times y is negative 2x plus 6. And that needs to equal negative 3. So negative x plus 4x minus 12 equals negative 3. So 3x equals, and if I add 12 to both sides, I'll get 9. So x is going to equal 3. So 3. And then I can plug that 3 in right here for my y. So y equals negative 2 times 3 plus 6. So y equals negative 6 plus 6, so y is going to equal 0. So got 2 of them. And then we'll come up here to the last one. So if I plug in 3 for x and 0 for y, z is going to equal negative 3 times 3 plus minus 0 plus 5. So negative 9 plus 5, which is negative 4. So there's my solution. That x, y, z triple will make all three of these equations true. That is going to take some concentration, that's all. All right, so that was no small feat. Nothing hard, but a lot of details. So if you don't force yourself to be careful with the details and the signs, there's just no way, right? So now they're going to also have us do Gaussian elimination. So that's another method. And this method has 2 main parts, okay? And they're going to break it down for us. And you just got to watch it and try it more than one time before you'll understand this page. But the first part involves eliminating variables from the equations in the system. And the second part involves solving for the variables one at a time. So instead of substitution, we're going to do elimination. So here's how they do it. They've got these, the system of 3 equations, okay? Step 1, use the first equation to eliminate x from the second equation. So you're just going to focus on this first pair, and you're going to eliminate x. So they do the steps to eliminate x, and then they've got this left, and then they put that in the spot for the second equation. So that's our second equation now, is this new one without an x in it. Then we're going to use the first equation to eliminate x from the third equation. So now we're doing this pair, okay? So we're going to eliminate x on that third one. So we have to multiply by -2, just like you've always done elimination, and then you combine them up and you get this, okay? So now that you've eliminated x from the third equation, you're going to make that be the third equation. So now the second and third equations don't have an x in them anymore. All right, so that was step 2, is getting the x's out of the second and third equation by using the first equation. So step 3 has us using the second equation, okay? The second equation, the new second equation, to eliminate y from the third equation. So now we're using these last two equations, these new two, okay, this one and this one. Oops. This one, sorry. This new middle equation and this new bottom equation, or basically these two, I guess. I'm going to use these two, the second and third equation. And we're going to do whatever we've got to do to eliminate y, okay, from the third equation. So if we look at these y's, we've got 2y and -3y. So if we multiply the top by 3 and the bottom by 2, then the y's would cancel out, and we would get this here, and then we could solve for z, and we'll get that z equals 2. So we can solve that for z then, and z equals 2. So then we're going to solve the second equation for y. So remember that second equation looked like this now. And so we plug 2 in for z and we solve for y. And now we know what z and what y are. So then we can plug those both into the first equation and figure out what x is. So there will be our solution. So first we eliminate x from both equations, then we eliminate y from the bottom equation, and then we start solving for variables. And then let's see what we can do. All right, now I will say on that last slide that I just recorded, it would be worthwhile for you to take that system and try solving it a few times until you find all the little mistakes that you tend to make and get those ironed out before you try too many of them. So basically, you start by eliminating x from the second and third equations, then eliminate y from the third equation, and then you can solve for z and solve for y and solve for x. So that's in a nutshell. Now that makes it sound pretty simple, but it's just a matter of being careful with all the detailed steps. All right, so we get one of these to try, and then they pop one on your test. So first thing I would do is go back to that last slide, get out some scratch paper, and try that multiple times until you can figure out where you make little mistakes and get that smoothed out. And then try this one, because the thing is, you got to get able to do it by yourself, and you get one to practice with. So I guess you need to do this one by yourself right here. So you got to pause me right now and try it, and then unpause me and see how you did. So well, there's no time like the present. Let's see how it goes. So hopefully you tried it. So this is my first equation, and we're supposed to eliminate x from the second one. So if I stack those up, I would have 2x plus y minus z equals -2. And to make my x's cross out, I'd have to multiply the second equation by -2. So I'm going to go ahead and do that. I would get -2x minus 4y minus 2z equals -22. Then my x's would eliminate. I'd have -3y minus 3z equals -24. All right, so that is my new second equation. Now I'm supposed to use the first one and the third one and I'm supposed to eliminate x. And you can see that those are already going to eliminate if I just stack them up. So I would have 2x plus y minus z. I'm going to cross my z's so they don't look like 2's. And then negative 2x plus y plus 2z equals 15. So those would eliminate. Now those y's, be careful. Some people will eliminate y and y, but they wouldn't make 0. They would make 2y. And then plus z equals 13. So that is my new third equation, okay? So I have equation 1, equation 2, and equation 3 now. Now I'm supposed to use equation 2 and 3 to eliminate y. So if I stack those up, I would have negative 3y minus 3z minus 24, equals negative 24. And the other one is 2y plus z equals 13. And to make my y's eliminate, I could multiply this bottom one by 3 and this top one by 2. So then I would have negative 6y minus 6z equals negative 48. And 6y plus 3z equals 39. These y's would eliminate. I would get negative 3z equals negative 9. So then I would divide and z would equal 3. So I already have one of my coordinates right there. Make sure I put it in the z position. Z is 3. So now we're going to find out what are x and y. So we can go back to equation number 2 and plug in 3 for z, figure out what y is. So negative 3y minus 3 times 3, which is what z is, equals negative 24. So negative 3y minus 9 equals negative 24. So negative 3y equals, 24 is kind of messy there. If I add 9 to negative 24, I'm going to get negative 15, and then I'll divide and I'll get y equals positive 5. So there's my y coordinate. And then I can plug z and y into equation number 1 here. So I would get 2x plus 5 minus 3 equals negative 2. So I just plugged in the y and the z into that first equation. So I would get 2x plus 2 equals 1. Equals negative 2. I don't know what I'm doing there. It equals negative 2. Sorry, I spaced out for a second. Negative 2. Then when I minus 2 from both sides, I'll get 2x equals negative 4. Remember, negative 2 minus 2 doesn't make 0. And x is going to equal negative 2. So there's my final coordinate. Negative 2, 5, and 3 is the ordered triple that will make all 3 of these original equations true if I plug them in for x, y, and z. Now, this right here is an extra credit opportunity. All right. It would be really good practice. So partner, okay, or yourself. So you can do this in twos if you want to. You're going to make a flow chart on notebook paper that summarizes the steps for solving a system of 3 equations by using either substitution or elimination. So whichever one you want to do, okay? And you're not going to present it to the class, you're just going to present it to me. You're going to use words and graphics that are going to help your classmates understand the steps. So you'll have a system. You might take one of the ones you've already solved so you know how, you know that it works out nicely. And you're going to say, all right, you know what a flow chart looks like? Do this first and then do this second and do this third. One step leads to another and it's really clear. You don't have to do it that shape, but it's really clear one thing at a time, and you could use words and work or pictures to help you explain that. So I'll make that worth 30 summative points. But just make sure it works, it's clear, it's pretty, it's not a mess, okay? If you're going to do it, you're going to get 30, right? You're not going to get half-baked 15. So that's an opportunity for you. Otherwise, moving on. Farmer plans to grow corn, soybeans, and wheat on his farm. C is going to represent the acres planted with corn. S is the number of acres with soybeans, and W is the number of acres planted with wheat. The farmer has 500 acres to plant with corn, soybeans, and wheat. Write an equation in terms of C, S, and W that models this information. Please don't copy me. Think about that. So basically, corn plus soybeans plus wheat has to equal 500. Growing an acre of corn costs $3.90, an acre of soybeans costs $1.90, and an acre of wheat costs $1.70. The farmer has a budget of $119,000 to spend on growing the crops. Now we're going to write an equation for the cost. So $3.90 corn plus $1.90 for the soybeans plus $1.70 for the wheat needs to equal $119,000 total. Farming's not cheap. The farmer plans to grow twice as many acres of wheat as acres of corn. Write an equation in terms of C and W that models this information. Whoa, think about that. It's not that complicated, but you got to think. You need an equation, okay, with C and W in it that says that twice as many acres of wheat as corn. So there's more wheat than corn, right? So the wheat would equal twice the corn. 2 times the corn is what the wheat would be. Does that make sense? Make sure. All right, now it's really, really, really important that you do this, that you try these things independently, because they're giving you basically one system to try. So they didn't tell us. They said take this system, so write it as a system of equations. So there's my 3 altogether, and that's the system. And they say solve it. And they don't say how. They don't say if you're going to use substitution or elimination, so you can do whatever you want. Now I'm going to think and look at it and decide which way is going to be easiest. But I want you to pause me and try it by yourself before you even hear the way I'm going to do it. It shouldn't matter which way you do it. Decide which way is going to be easiest for you. Pause me right now. Okay, try it. All right, well, hopefully you tried. Now I notice that I already have one variable solved. I know that W equals 2C. So I'm going to do substitution, because then I could just put this in to the first equation, and then I would have 3C plus S equals 500. And then it's really easy to solve for S. S is going to equal negative 3C plus 500. So the cool thing is, now I know what S equals and I know what W equals, and they're both in terms of C, which means that if I go to this equation I haven't used yet, and I put these in for W and for S, and I make the substitution, I'll have only C's in my equation and I can solve it. So it would look like this: 390C plus 190S, and S is negative 3C plus 500, and then plus 170 for the wheat, and the wheat is 2C, and that all needs to equal 119,000. All right, so yeah, these are some high numbers, but I'd have negative 570C plus 95,000 plus 340C equals 119,000. And then when I combine like terms here, let's see, I better not mess this up. So we'll get the old calculator out. 390 minus 570 plus 340 gives me 160. C. And then if I minus this 95,000 to both sides, I'll have 5,000 plus 19,000, so that'll be 24,000. And then I'll divide that by 160. And I'll get C equals 150, okay? So I've got the first part of my triple. C is 150, so that's C, and then I'll have S, and then I'll have W. Well, I already know that W equals 2C, right? So W is twice as much as the corn, so 2 times 150. So I already know that W is 300. And then I already know that all three of these have to add up to 500, right? So I would have corn and wheat, I'll just put those together, plus my soybeans need to equal 500. So my soybeans are going to have to equal 500 minus 450, which would leave me with 50 acres of soybeans. So 150 acres of corn, 50 acres of soybeans, and 300 acres of wheat is what this farmer can do. Now do you see how math comes in handy? You don't want to screw that up or you're out a lot of money. 119,000 for growing your crops. That's just 1 year. All right. So we already sort of did explain this. The farmer can plant, what was it, 150 acres of corn, 50 acres of soybeans, and 300 acres of wheat to meet his requirements, because his requirements are that he has twice as much wheat as corn, and he has 500 acres total, and it needs to all add up to, with the cost of each crop, add up to 119,000. I dare say that is plenty enough for this lesson, and we'll pick it up together in class. That's going to take you some time though, guys. You're going to have to practice that stuff more than just that, obviously. So do what it takes to be who you want to be. See you in class.